Okay, here are two more expected values tables to fill out. Suppose you play a game with a biased coin. You play each game by tossing the coin once. Probability of getting ahead is 2/3 and the probability of tails is 1/3. If you toss a head, you pay $6. If you toss a tail, you win 10. So head is lose 6, tail is win 10. If you play this game many times, will you come out ahead? So you've got a win or a loss. Win is $10 win. A lose is a negative $6 loss. This win is a tail, and the lose is a head. So probability of heads is 2/3. Probability of tails is 1/3. So this is 10 times that 1/3, or 10/3. And the other one was 6 times 6 times 2/3, which gave you a negative 12/3. So what you end up with when you add them together, 10/3 minus 12/3 is negative 2/3. No, you do not come out ahead. You come out with a loss every time. Okay. Suppose you play a game with a spinner. You play each game by spinning the spinner once. Probability of a red is 2/5. Okay. Probability of a blue is 2/5. The probability of green is 1/5. If you land on red, you pay $10. If you land on blue, you don't pay or win anything. That's a 0. If you land on green, you win $10. Complete the following expected value table. Negative 10 times 2/5 is negative 20/5. 0 times 2/5 is a 0. And 10 times 1/5 is 10/5. So this actually is a negative 4, and this is actually a positive 2. So in this case, you'd be down $2 every single time. And those are just a couple of examples for you. I'm going to post those. The next thing we're going to is the standard deviation. I'm going to make a separate video for that, though.